All right, so this is a day one lesson of 2 days again. And today our essential question is, how do I add rational expressions?
So adding rational expressions is the same thing as adding fractions.
Oh,
So the easy way to add fractions together is if they have the same denominator.
common denominator.
Remember, you don't add the denominator stays a 5 like it is where Miss Boyd highlighted, and you add the numerator. 1 plus 3 is 4.
Perfect.
Same with the next one, the 7. 6 minus 4 is 2. So we're going to start this lesson with very easy problems that have the same denominator.
Oh, good.
But obviously, it's not going to stay that way.
No, you're going to have to find a common denominator.
Yep, and
Okay.
we'll go over that in a little bit. So example 1, what I like to do, Miss Boyd, is I like to rewrite it so it's all over one denominator. I kind of,
Okay.
do you see what I'm saying?
Mhm.
Yeah.
So we'll have x minus 3
Plus
plus x minus 2 all over,
right.
and we just write it one time.
Yep.
X plus 4. Because they were the same, we could
Yep.
add the tops.
Mm-hmm.
Okay,
So now
we
you
just
add
combine the
like terms. X plus x is,
2x.
right? And then be careful, it's a negative 3. The sign in front of it goes with it.
Negative 2 is negative 5.
Right.
All over
X plus 4. And guess what?
We're done.
But notice what it says. Identify any x values for which the expression is undefined.
So x plus 4, we just set it equal to 0. Subtract 4.
Correct.
So x cannot equal negative 4.
And notice Miss
Otherwise it would
Boyd
be 0.
changed it to, x cannot equal.
Right.
Because we're not saying x equals negative 4.
No.
We're trying to find out what x value will make our denominator equal to 0. Because you can't ever have 0 in your
Because
denominator.
underneath the bar is undefined.
Correct.
Okay.
So, you know what?
What?
I forgot I threw one in. We better do this one. And I bet you know, I bet you
I
see
do.
what I see.
We have a minus sign.
Right.
So I like to put this all in parentheses.
Yes, so do I.
Because we have to distribute this negative
Right.
to everything.
And I still put it all over the 3x minus 1.
Right away.
Oh, I see what you're doing. Oh, well,
I was going to distribute it
yes.
now while I was
Oh,
going.
yes,
Okay,
definitely.
good.
I'm good with
So
that.
when we distribute, this changes to a plus, and now we change every sign inside. So this was positive, so now it's a negative 2x squared. This was negative, so now it's a positive 3x. And this was negative, so now it's a positive 2. And now it's all over the same thing, 3x minus 1.
Right.
Great. Now we can combine our like terms.
So we
So
have,
I've got a 3x squared and a negative 2x squared gives me just a x squared.
yep.
I like to go in order.
I do
I've got
too.
a plus 3x, no other x's, so plus 3x. And then I'll box it in. I've got a negative 5 and a positive 2, which gives me a negative 3.
Correct.
All over 3x minus 1.
And we're done.
Great.
And now, this is a little more tricky, Miss Boyd. We have to identify the x values for which the expression is undefined. So some of you can look right at that and see it's 1/3.
Right.
But Miss Boyd's going to set the denominator
one
equal
equals
to
0.
0, and we're going to solve.
So we're going to add 1, so we get 3x equals 1.
And I'm going to scroll
Thank you.
down.
Divide by 3, divide by 3. So x cannot
Cannot
equal
1/3. There's your 2 answers.
Okay.
You must do that.
Great.
All right, next. To add or subtract rational expressions with unlike denominators, you must first find the least common denominator. And what that is, it's the least common denominator is the least common multiple. We're going to go over this.
Okay.
The least common multiple of the polynomials in the denominators. Lots of words.
Yeah.
Lots of words. So look at my little table I have here.
Okay.
To find the least common multiple, you have to factor first. Okay?
Okay.
Then what we're going to do is we're going to list the different factors. If the polynomials have common factors, we're going to use the highest power of each common factor. Now still, that's a lot of words.
Yeah, I'm
So
just going to have to
are you
play
ready?
along. Let's do it.
Let's do an
Yeah,
example.
Let's just do it.
So look at what I'm having you do.
Okay.
I'm having you practice.
Great.
Find the least common multiple. What we're doing right now is we're practicing
to get-
getting a common denominator. Okay? So you have to
Right.
factor each one. That's why I have an equal sign
Yep.
over there.
So we can't take anything out. So
Nope.
now we factor. So what do we multiply to get a -3, but add to get a -2? -3 and 1.
1.
Okay, so x minus x.
It should be
that's
plus, yes.
Thank you.
Now, notice how quickly Miss Boyd did that. That's where you should be at. That's why back when we were factoring, we took a lot of time because you're going to use this a lot.
Yes.
So if you need help with factoring, you better come and visit one of us.
All right, we can't take anything out, so we ask ourselves, what can we multiply to get a -6, but get a -1?
Add to a
Add
negative
to get
1.
a -1. So that's -3 and 2. So that's x minus 3 and x plus 2. Ooh, here's our common.
Can you change that to extent?
Oh, yeah, sorry.
So notice, -3 times 2 is a negative, I'm going over the factor, is -6, and -3 plus 2, that's our -1. So now, write LCM, uppercase L, uppercase C, uppercase M, equals the least common multiple. What we do now is we list every single factor.
But we don't repeat it.
Exactly.
Okay, so we got an x minus 3. We've got an x plus 1. And we don't have to write this again.
Nope.
And then an x plus 2.
That is the least common multiple. That's how you do that.
Okay.
Example 4 is doing that again. Do you want to save that one for class? Okay.
Yeah.
So example 5, here's our time to practice.
Okay.
So we're going to add, and notice the denominators are different. Right away, you have to factor, just like we did back in the last problem.
Yep. So this one's already factored. So this one can be, since it's a, what's that called, perfect?
It's, yep, a difference of two perfect squares.
So we have
it's going to be x plus 2
and
x minus 2. Now, what I'm going to have Miss Boyd do right now is draw a single line across the bottom.
Okay. 1 second here. We're just
I want you to rewrite that. That's what I want you to do.
Yeah.
Okay? So x over
x over
x plus 2
x plus 2
plus
-8
over
now
x
our
plus
new
2
one, we expanded it out.
and x minus 2.
Okay.
Okay. Draw that line. Okay. Now Miss Boyd's going to go down and draw one big long line. And guess what she's going to put in the denominator? The least common multiple, which is going to be x plus 2.
Well, they each have an x plus 2.
Yeah. And an x minus 2.
And an x minus 2.
So now we have to ask a question. Let's go back up. Can you just put a box around this so we know what that I'm focusing on that one only.
Okay.
You're going to look now at your denominator and you're going to say,
how do we go from here to here?
How do you go from the x plus 2 to the, can you point to the new one? To the new one, which is down there. It's missing what, Miss Boyd?
The x minus 2.
So you have to multiply the top and bottom by x minus 2. Okay, and do a little line to show. See?
Okay.
Now ignore that right now. Now go to the other side. Okay? Well, look.
We're fine.
We don't have to do anything to that one. Okay, so now let's go back over to the other one and let's actually multiply.
So x times x
is x squared. And
negative
2
times x
is negative 2x.
And now we bring this down.
Negative 8.
So minus.
Now we can do that because it's a they have the same denominator. So now we can do that.
Great.
So now guess what we're going to do, Miss Boyd?
Well, I think we can factor the top.
Yep. Notice the word factor. Oh boy, you're using that a lot.
All right, so what two numbers multiply to get a -8, but add to get a -2? That's -4 and +2. So I'm just going to do this so I remember. All right, and then put our x's in, x plus, and we're going to put it all over our common denominator now of x plus 2, x minus 2.
And I'm going to scroll down for Miss Boyd a little bit.
Now we have Miss Young's favorite
thing.
The x plus 2 and the x plus 2 cancel.
Yay!
So we are left with x minus 4 over x minus 2.
And guess what, though?
Oh, we're not done.
What values of x make it undefined?
And we have to do it for both of these,
Yes,
right?
students want to tell me just 2, and that's wrong.
So we need to do x plus 2 equals 0.
Right.
And x minus 2 equals 0.
And you don't have to show that work.
No, if you know it.
If you know it, you can.
Because you know x cannot equal -2.
Right. And here x cannot equal 2.
2.
So can you circle or highlight those so we know those are both part of the answer?
Yes.
You have to have everything we circled is the answer.
All right.
So
Great.
we have a 6. I think we should
Let's
save our
it for
6.
class, yeah.
And we have a 7. And
Which we could probably save for class.
okay, you want to do that?
Yep.
Okay.
Let's scroll
So
up
I'm
just
going
a
to
little bit.
scroll.
There we go.
There we go.
Perfect.
So you're going to add, and notice number 1 is quite easy.
Yes, same common denominator, so we're good.
And number 2 isn't hard. All you're
is
doing at
finding
number
the
2
common
is
multiple.
finding the least common multiple for each pair.
Great.
We did an example of that. You will be fine.
All right, see you tomorrow.